Welcome back to Saxon Math. This is lesson 36, subtracting fractions and mixed numbers from whole numbers. This is also, this is where it's apparently a new concept, but it is a separating word problem that we're going to look at here to start off the lesson. There were 4 pies on the shelf. So you see 1, 2, 3, 4. One of the servers sliced one of the pies into 6 pieces. So you can see that one of the pies is sliced into 6 equal pieces right here. 1, 2, 3, 4, 5, 6 equal slices. The servers took 2 1/6 of the pie from the shelf. So 2 whole pies were removed from the shelf and 1/6 was also taken. So that means we had at least 12 slices here and 13 slices in total were taken off of the shelf. Now that you've seen that picture, you can also see that there is a remaining 1 whole pie, and 1, 2, 3, 4, 5 of those pieces from the original whole pie here that was sliced into 6 equal parts. So that's 5/6. So the remaining portion out of those 4, you have 1, 2, 3, 4 whole pies, which is the same as 3 6/6. That equals 4 whole pies. This one piece, or this one pie, was split into 6 equal parts out of 6 total equal parts. So that was the same as 3 plus 1. You'd end up with 4 again, which is what we have here. We have 4 equal pies. If you take 2 whole pies out of there, that's pretty easy. You can see, oh, there's just 1 whole pie left. And then this last pie here was 6/6, which is the same as 1, but 1 slice out of that 6/6 was 1/6, and 1/6 was taken from it. So these were all served up. So these got gobbled up, basically. These are gone now. That 2 1/6, somebody ate those. What's left on the shelf is 1 whole pie with 5/6. Let's look at another example here. So if you're to subtract 5, and if you've got 5 minus 1 2/3, then write a word problem that's solved by the subtraction, you would simply have to make sure that you borrow from the 5 so that you have something to subtract. If you have 5 minus 1 2/3, just as you see here, 5 minus 1 2/3 can't be done until we have something to subtract for the fraction portion of this mixed number. So if you have 5, you can convert that into a 4 3/3, which is now the same as 5. See, it's still the value of 5 because 3 divided by 3 is 1, and 1 plus 4 is 5. And why did we choose 3/3? Because we could have also said 4 4/4. We could have said 4 5/5. We could have said 4 6/6. We could have said 4 178 over 178. You could have said 4 25 over 25. Those are all equal to 5. Those all equal 5 every time. As long as this value is 1, 1 plus 4 equals 5. Let me just get rid of that so it's not so confusing. But the value of this 5 has to remain the same, and it does if we keep this as 1 plus 4. And we're doing that by having the same numerator as the denominator. And the reason why we chose 3 is because we are subtracting a fraction or a mixed number that has a denominator of 3. So that's an easy choice. We have to make sure we have 3 here, and if we have 3 for this denominator, we have to make sure we have 3 for the numerator. So that's why we have 4 3/3 minus 1 2/3. Now you can subtract this. 3 minus this 2 equals 1, and the denominator remains 3, and 4 minus 1 equals 3. So common subtraction word problems are about comparing or separating. So here's a sample word problem of this. If a clerk cuts 1 2/3 yards of fabric from a 5-yard length, how many yards of fabric remain? So 1 2/3 was subtracted from 5. We would have 3 1/3 yards of fabric remaining. So why do we need to change 5 to 4 3/3 before we subtract 1 2/3 from 5? Because you need to have something to subtract the fraction portion of the mixed number. So we have to borrow from that whole value. Let's try that a little bit. So letter A, go ahead and give that a shot, and I'll show you if you were correct here in a second. All right, for letter A, here's what I want to do. I want to set this up. 3 minus 2 1/2. I'm going to write it like this, but I have to recognize there is no value here to subtract, so I have to borrow. So I'm going to borrow from this particular 3. That's going to become a 2, and then it's the same as 2 2/2. So I have 2 2/2 because there was a 2 here. So I'm making this 2 as well. And this has to be a 2 because it has to be the value of 1. 1 plus 2 is 3. So we still have 3 minus 2 1/2. We still have 3 because, check this out, 2 2/2 is the exact same value as 3. So we still have 3 minus 2 1/2 essentially. So now you have 2 minus 1, which is 1. The 2 in the denominator remains the same. When adding and subtracting fractions, the denominator remains the same. They have to be the same denominator, and then they remain that denominator. And then you have 2 minus 2, which is 0. You don't have to write 0 in front of a half. So A would be 1/2. Okay, go ahead and do letter B. For letter B, start it again like this. 2 minus, and in this case it's 1/4. There's no whole value that we're subtracting. So here's what I'm going to do. I'm going to borrow from that 2. I'm going to borrow 1 4/4. I'm essentially renaming it. It's just been renamed is all that happened there. I didn't actually do a whole lot to it because it's still valued at 2. 1 plus 1 equals 2. So now I have 4 minus 1 here for 3. The 4 in the denominator remains the same, and then I have 1 minus. There's nothing here technically, so 1 would be the answer to that. For letter B, 2 minus 1/4 would be 1 3/4. Some of you may have done that mentally, but this is how you show the arithmetic for each of these problems. Okay, let's do letter C. Let me set this one up for you if in case you failed miserably at letter A and B. Let me start this out for you. Letter C, 4 minus 2 1/4. So it should look like that when I'm writing it on my paper. Go ahead and try it. Okay, so again, I need to borrow or rename. This is going to be 3 4/4. Why did I choose 4? Because this is a 4. That denominator is a 4, so I'm going to choose that one. Now I have 4 minus 1 equaling 3, and the denominator stays the same, 4, and 3 minus 2 equals 1. So this would be my answer for letter C. You would have 1 3/4. 1 3/4. And then letter D. Go ahead and do that all by your lonesome. Letter D. Should have been 3 minus 5/12, just like this. I have space for a whole number value here. I don't have one, but I now need to borrow or rename this. I'm going to take this, change it to 2, and I need to use 12 twelfths as the number or the fraction portion of that mixed number, because this is a 12 in the denominator. So I have 12 minus 5 equaling 7. The denominator is 12. And then it's 2 minus nothing there, which would be 2. So the answer to this one for letter D should be 2 and 7 twelfths. All right, let's try some more. Letter E. In this one, it's 10 minus 2.5. Go ahead and do that. So again, I'm going to write 10 as the whole values, and then I have to have 2.5. And I'm going to write it vertically like this. I'm going to borrow or rename this. This will be 9. I'm going to borrow one set to put into the fraction portion. And since this is a 2 in the denominator, I'm going to use 2 halves over here because that needs to be worth 1. 1 plus 9 equals 10. Now I just subtract the numerators. 2 minus 1 equals 1. And then the half, the 2 remains 2. And now I have 9 minus 2, which equals 7. So that means 10 minus 2.5 is 7.5. To letter F. You should have started with 6 minus, and you have 1 as the whole number, and then 3/10 as the fraction portion of that mixed number. Now I need to rename or borrow from this. This would become 5 and 10/10, because 10 over 10 is what I need to choose because this denominator is a 10. Once I've completed that portion, now I just take 10 minus 3, which is 7. The 10 remains as the denominator when adding and subtracting fractions. And the whole numbers, I have 5 minus 1 equaling 4. So I should have 4 and 7/10 for the answer to this one. All right, letter G. What does this model represent? Does this model represent 5 minus 1.5 equaling 2 3/5? So if you were to recognize that this is like arrows drawn here, so 5 minus 1.5 equals 2 3/5, or is this 6 minus 1.5 equals 3 2/3, or is this letter C, 5 minus 2 1/4 equals 2 3/4, or is this letter D, 2 3/4 minus 2 1/4 equals 2 3/4? All right, if you chose, let's see, 1, 2, 3, 4, 5 holes, so it can't be this one and it can't be this one because it's not 5 holes to start off with. And here's 2 parts with 1/4 of this last piece subtracted from that, and I see there's 1, 2 holes there and 3/4. If you chose letter C, you were correct. You can see that this one is more than 1.5. This is actually 2 1/4. It's not even 1 hole. It's 2 holes, so it's not going to be that one either. So if you chose C, you chose wisely. You can see that it was 2 1/4 taken away from 5 whole parts. 1, 2, 3, 4, 5. This one just had to be split up into 4/4. So it was like having 1, 2, 3, 4 holes, and the last hole just being split up into 4 equal pieces to create that model. Using letter E, which states 10 minus 2.5, which word problem best suits the exercise for E? Would it be A, Bob had 10 chickens and 2 chicks were hatched? How many chickens does Bob have now? Or would it be B, Sam cut 2.5 feet from a 10-foot long board? How long is the board now? Or would it be C? Joe Boy found 2.5 pineapples at the top of the cliff. He had 10 pineapples in his yard at home. How many does he have now? Or would it be D? There were 10 little monkeys jumping on the bed. One fell off and broke his head. They called the doctor and found out he needed to take 2.5 Advil and he'd be better. How many monkeys were still jumping on the bed? So looking at this, 10 minus 2.5, you've got 10 and 2.5 there, you've got 2.5 here, you have 10 there, you have 2.5 and 10, you have 10 and 2. This one is probably most definitely not going to be it because it doesn't have 2.5. Can't really have half a chick. Sam cut 2.5 feet from a 10-foot long board. How long is the board now? Okay, so this is probable. Found, he had 10 and he found some, so if he found some, he's actually adding to his pile, so it can't be that. This is a subtraction problem. 10 little monkeys jumping on the bed, he needed to take 2.5 Advil, so that taking Advil and jumping 10 of them jumping on the bed doesn't have anything really related to each other. And you know, if we're talking about one monkey no longer jumping on the bed, that's not 2.5 monkeys, so it's definitely not going to be this one. If you chose letter B, you chose wisely. Nice job. All right, that should be, sorry, I almost jumped the gun there on letting you loose. You've got one more problem here. Write a word problem similar to I and then find the answer. So you have to actually create a word problem. I guess, sorry, letter I hasn't been complete. Let me find letter I for us. I believe I can find letter I in here. Letter I, yes, there's letter I. So there were 4 whole pies on the shelf. The server took 1 5/6 pies. How many pies were left on the shelf? So let me just give you time to do letter I first. Letter I. There were 4 whole pies on the shelf. So let me just draw those real quick. 1, 2, 3, 4 whole pies on the shelf. The server took 1 5/6 pies. How many pies were left on the shelf? So 1 pie is going bye-bye. And then this last pie needs to be split into 6 equal parts. So if you're taking 5 of those, you have 1 piece left, so you have these 2 pieces, so you've got 1, 2, that's 2 wholes, and then you have 1/6 left remaining. So there should be 2 1/6 pies remaining on the shelf. If that was your answer for letter I, you are correct. And letter J, this is up for grabs. You just need to write a word problem that's similar to letter I here, and then find the answer and give me the answer. So you might use, there were a different number of pies on the shelf and the server took a different number of pies off of the shelf, and how many pies are left. You could change it from pies to something else, get a little creative. Anyone's answer just needs to be checked. You need to make sure your word problem is similar to I and then it has an answer to it. Excellent work. We'll see you guys tomorrow. And don't forget, you're going to be doing written practice 1 through 30 during class.